Okay, so today's lesson 11 for linear regression. We're going to learn how to do those equations we were writing last week on the graphing calculator. We're going to be using desmos.com. So there's a sheet of calculator instructions in the work for today. So I would print that or make sure you have it handy. I'm going to lead you and show you how to do it for the video, but I would have the sheet handy so you could follow the step by step. So it looks like this: calculator instructions. And then it tells you if you're creating a scatter plot, follow these steps: to find the linear regression, to find the correlation coefficient, to find the residual, and to predict the value. So depending on what the question asks you, you're going to always have to create the scatter plot. But after that, these things you're going to have to do the parts that the question asks you to do. All right, so the first thing we're going to do is open desmos.com, which I have here, and click that plus sign in the corner. So that's how you're always going to start with that. Apology for all the background noise at my house today. So hit the plus sign, and then you're going to pick table. And I already put the data points in the table here. So that's what you're going to do first. So on our paper, 11 for linear regressions, the best fit line is a line created by the calculator using algorithms. It's basically drawing in that line you were doing by hand, but it's going to do the best line possible to fit the points. The linear regression is one of the algorithms that's used to create that line. So that's what the calculator is doing behind the scenes. The correlation coefficient tells you if the correlation is positive or negative. So we talked about positive negative correlation in the problems last week, and how close the equation is to modeling your data well. The closer to 1 or negative 1, the more closely it models your data. So if you get a correlation coefficient of negative 0.99, you know that that data is very closely related. If you get a correlation coefficient of negative 0.5, it's less closely related because that's further away from 1. If you get positive, it just means it's positively related. So a negative means it's a negative correlation. A positive would be a positive correlation. So example 1, the table shows the amount of money made by movies in the United States. Using a graphing calculator, write the equation of best fit and record the correlation coefficient. So in these years, this is the amount of income from movies produced. So, and it's in billions. Okay, so I put all this data already in the calculator. So you can see that's all the years and all the data. So you don't have to do this for the video. You're going to have to do this on the other examples. The video is your guide. Okay, so the data is all in the calculator. So if you look at the directions, it says put the data in, choose a table, enter the X values in the first column. When you're looking at your data set, the X values are always the first ones listed, and then the Y in your second column. So I have the years in the X and the income in the second. And then it says, be sure to click on the wrench. So if we look at the directions here, click on the wrench in the upper right corner and set the X and Y axis to match the coordinates listed. So where is that? If we go back to our Desmos, if we go in the upper right corner, there's a wrench, and it asks you for the X axis and the Y axis. So our years are from 2000 to 2009. I usually go about 10 below. So we're going to go to 1990. 1990, and then it says to 2009, so we can go up to, I'm just going to go up to 2020. So we have somewhere around 10 above and 10 below. For the y-axis, the numbers, the lowest number is 7.48, so we'll go down by, if we go down by approximately 10, we can go down to 0. And then the highest number was 10 point something, so we'll go up to 20. So again, you just want to make the window bigger than they give you. And now you should see on your screen the data points. See them? And the numbers on the bottom show your scale. So we have 1990 over to 2020, and up the side we have from 0 up to 20, like we told it to do. And there's our data points. So now we want to create the line. So if you look on the calculator directions, it says to find the linear regression, click on box 2. On the left side. So there's the box 2 on the left side, and it tells you type in Y1, and then that little swiggle line, I always forget what it's called, a tilde or something like that, I think, mx1 plus b. So we're going to type in Y and that little swiggle line, and then m, and then x1, and then plus b. And when you're doing the 1, oops, I forgot my Y, it's supposed to be Y1. When you type in the 1, you just type a normal 1. Okay, you don't have to put in, it puts it as a subset for you. So Y1, the swiggle, M, X1 plus B, and you're going to see all this stuff pop up underneath. The statistics, this is where you get your correlation coefficient. The R2 is a residual. The R1 is the correlation of regular R. This residual we're going to talk about in a minute is here. The parameters are your M and B. So if we want to write the equation on our paper, we're going to write, and this is what you're going to do. You're going to write this down. Y equals, we're going to go find the M, which in this particular problem is 0.023. So 0.23 x, and then the B is negative 456.03, so minus 456.03. So you see how what we were doing last week with point slope form, sorry this is jumping all over the place, but last week we were doing this calculation by ourselves, by picking 2 points and doing point slope. Now we're using the calculator to do it for you. So the Desmos calculates it for you. It draws the line in for you. You can see the information. You can see the best fit line. That is the calculator did all the work out to figure out what line worked best, and it gave you the equation of the line right there. So the next part of the notes talks about residual. And residual is a difference between an observed, this should be an observed value, and its predicted value. So if you think about your line of fit, that's prediction. What actually happened is the observed. The difference between both is how we figure out how far the data deviates from the line that you just formed. It determines whether the best fit line is a good line. And so if we look at this, basically what it's doing is finding the difference between each point and the line that was just created. The difference between each point and the line that's created. So to do this, if you look at your directions, to find the linear regression equation, underneath that it says to find the correlation coefficient, which I forgot this problem asked us to list. It's where it's the R value, so that's right on the screen. So for this particular problem, after we write this, the correlation coefficient is always R. You can just put R equals 0.8755. So that tells me that the data is positively correlated because it's positive. And 0.8755 is close to 1. It's not exactly 1. So it's close but not perfect as far as predicting the data. And then residual, if we want to find example 2, says you use that data and get the residual. So to do that, the directions say to find the residual, click on the plot under residuals. So if we go back here and we click the word plot under residuals, and we look at our calculator, you might not see it, you might have to scroll a little bit, but you see those lines along the x-axis? That's the residual. That tells you from the line how far off it is. So you see how this point is a little below because it was below the line. This one's right on. It tells you how far off it is. A perfect prediction equation would be all at 0. It would follow right along the 0 line, but this one is above and below some. So to answer the question on your notes, it says use a data to say if it's the best fit model. You could say many points are close to 0. However, a few are off, so it is not a perfect model. So what does that mean? If we look at this overall situation, that best fit line is pretty good, but there are some points that are not perfect. So that's why that correlation coefficient is not 1. And you can see the residuals are not all at 0. So that's how all that data relates. So now we're going to look at example 3. So example 3 says a table shows the points received by the top 10 paintball teams at a tournament. Find the linear regression model. Record the correlation coefficient and estimate how many points the 20th ranked team received. So the first thing we're going to have to do, and it says using your graphing calculator and following our directions, we're going to have to go to Desmos.com and we're going to have to put the plus sign in the corner, which I did this already, pick table. And then once again, you're going to put your rank as the X values and the score as the Y values. And then the next thing it says is we have to, if we look at that, you see no points on your table. So this is where you got to go to the wrench. And you click on the wrench and you're going to set your X values. So the lowest one is 1, the highest is 10. So I would say -10 up to 20. Okay, and then the y values start at 64 and go up to 100. So let's go to 54, and then we can go up past 100, say to 110. And now we should see our scatter plot. So there it is. Now if you look at this, you might say, well, those are scattered pretty well, but there is still that negative trend if you think through the data. So we are going to continue this problem and know that it's not going to be as accurate. So it does tell us to find the linear regression. To do that, we stick on the number 2, reading your directions, click on box 2, and type in y1, and then that squiggle mx1 plus b. And there's all our data. There's the line that forms and all the data. So on your paper, you're going to record y equals, and then if we look at the parameters here, m is negative 3.15 and b is 105.33. So negative 3.31 is going to round to 2. X plus 105.33. And 2 decimal places is fine to round your numbers. So that's our answer for that first part. What is a linear regression model? There it is. Then it says record the correlation coefficient. So we go back up and we're looking for the R value, which is negative 0.76. So we're going to put R equals negative 0.76. So again, the relationship is negative as the rank goes up. So at rank number 1, so as the rank goes down technically in this case, but as the rank numbers go up, the scores go down. So the first place should score the highest, and then going down from there is what that is saying. So it's a negative correlation. Okay, it's not that close to 1. So this is, as you can see, the scatter plot is pretty scattered compared to the line. So that's why it's a 0.76 is further away from 1. Okay, then it says estimate how many points a 20th ranked team received. We haven't done this yet, but if you go back to your direction page to predict a value, click on the line of fit at the value you're looking for and record the corresponding coordinate. So we're going to go to our line of fit and we're going to find 20. And in this particular case, it's kind of off my screen. We need the y coordinate or x coordinate to be 20. So when we get there, we're going to click on the line and make sure it says 20, comma, and then whatever the value is. So this predicts that at the 20th ranked team, they'd score 39 points. So then we're going to record that on our paper. Okay, so the 20th ranked would be predicted to score 39 points. And you should make sure it makes sense on your table. So we're going 1, 2, 3, 4. We get to 20. As you can see, the numbers are going down. So it makes sense that the 20th ranked team would be a lower value. Okay, so as the rank goes up, the score points go down. So when you get to the worksheet, which I have here, and you start doing these problems on the worksheet, read the directions carefully. You have to put the numbers in like we did on every one. So you have to follow the directions and create the scatter plot on every problem. Okay? Then you have to read and say, what does it ask me to do? Write the equation and the correlation coefficient. So you're going to have to do for those ones, find the equation and correlation coefficient. That's for 1 and 2. When you get to number 3, it says write the equation, graph the residual, and determine if it's a good model. So you're going to do the equation and then the residual. So read the directions carefully. Then when you get to number 4, it says find an equation and then predict a value. So then for that one, you're going to do the equation and to predict a value. So read what the directions say and do those parts of the calculator instructions.